Hello everyone, and this is Motion Design School. On this lesson, we are going to answer the most frequently asked question: how to loop animation, how to make it have a look like it has no joints and keep the motion happen in the most natural way. And of course, we will learn about animation loop types in general. So let's find out what is looped animation. When you create a GIF, the animation is already looped. Certain frame sequence is being played from the start over and over again. But in animation loops, beginning and ending of actions must be invisible. Movements must smoothly flow from one phase to another. And by the way, during this lesson we will be considering new helpful expressions that you can also find with this attached project. So let's understand everything with the help of examples. We will start from the ordinary loop. It is a simple repeat of one action, and this one will be used as a base for considering other loop types. Create a new composition, size 600 by 600, 30 frames per second, and duration of 4 seconds. Draw a tree. Now let's create the ground. Duplicate the tree layer, scale it up to 500%, rotate it to -90 degrees, and place it lower according to the grid. Now select the tree, move its anchor point to the bottom, and open rotation property and create swings from -15 to 15 degrees. Move 20 frames further and change its value to 15. Easy the keyframes by pressing F9. So we want this tree to swing continuously. That can be achieved in many ways. For example, we can copy these keyframes and paste them each 20 frames. Or we can just copy the first keyframe and paste it here and apply the loop out expression that was mentioned on previous lessons. But instead, we will do this with only two. For that, we will set up the loop type. Inside loop out function. So type loop out, and now type ping pong in brackets. And watch what will happen. As you can see, this parameter makes the loop out expression play the animation back and forth. It's really useful when we need to loop the movement with symmetric speed graphs like this. And the tree swings, but that's not cool enough, so let's add some bend to it. After Effects has built-in effect called CC Bend It. It bends the object. As you can see, this effect has created 2 points, start and end. But be careful, if the end point is placed not high enough, the layer will be cropped. That's because the invisible rectangular grid is created between the start and end points, which effect uses to bend the object. All we have to do in case to fix this is just drag the end point higher. Well, now we have to make the start and end points move with the tree to make the bend work properly. Just click with Hold Alt on Start and End parameters and type expression to comp and in brackets value. Copy and paste it to the expression field of end parameter. And now the object disappears, because start and end flew away. Just drag them to the right place. Let's animate the main bend parameter. Let's animate the bend parameter. Create a keyframe on the bend and set the value of 35 in the beginning of a timeline. Then move to 20 frames and set the value of -35. Make easy ease and add loop out ping pong expression to it. So now we have swinging tree animation, but these swings are not cool enough. To make it more natural, select the bend keyframes and offset them approximately on 5 frames. Now it's much better. Due to the little rotation delay, the movement became more natural. This trick is called animation offset. It is really often used in animation process. So that we silently came to the next loop type. loop with offsets. This is a certain amount of ordinary loops, but with time offsets between them. Go to Project Panel and duplicate our tree composition. And let's open this composition. Let's duplicate our trees and make them different in scale. Place them like this and offset them on a timeline. Now we have the loop with offsets. By the way, we can make this type of loop not only by offsetting duplicates of one animated object. We can complement it with another loop's animation. For example, we added these fighting ducks. So how to make the right offset so that all actions will be looped, even when we have a lot of them? The first thing you have to understand is dependence of movement duration from loop duration. For example, we are going to create a loop of 30 frames long. All animation with repeats or without them must fit this duration. They can have duration of 5, 6, 10 or 15 frames. So there must be no remainder on dividing 30 by duration of animation. So if we made a loop in which all the animation's durations are multiples of 5 and the only one is multiple of 12, we would have to make the loop at least 60 frames long. And the next important thing is offset size. You can offset animation forward and backward maximum on half of action duration. Usually, you'll get a quite strange synchronism with half duration offset, and after half, you'll get the same result as you would have with offset in opposite direction. And the another interesting thing about the ducks is that they animated with paths. And the question appears, how to loop path animations, if loop out doesn't work in these cases. So, for this, we have a special expression for you. I will demonstrate its work on a real example, create a new composition and draw a simple path. Animate it like this. If we put a default loop-out expression to the path, it won't work, because it works only with properties which have numeric values. But if you paste here a special expression, everything will work like it should. You can copy this expression from the description to this video. This expression creates a time remapping simulation, playing all the things between first and last keyframes. By default, ping-pong is switched on in this expression. Just change this true to false in case you want a simple cycle animation. This expression is cross-functional, so you can loop any property using it. Just paste it in expression field of any animated parameter. And the next type is continuous loop. It calls this way because it creates the illusion of continuous movement. On the following example, it is used for camera movement in 2D space. And on this example is used for camera movement in 3D space. It's pretty simple, so we won't stop on this type. But we will consider in details the next type, recursion. It is a particular case of continuous loop. We can describe this as infinite appearing of similar objects directly from themselves. The most vivid example is Fractal. It's really easy to get sucked into well-done recursion. This is the main thing about it. You know what I mean if once you have spent more than 1 minute looking on one animation. So let's create the simplest recursion example from our tree. Duplicate the composition with the loop tree in Project Panel. Delete all keyframes from its properties. Reset its values. And replace anchor point to the center of object. It's our base, and now let's make a leaf or small branch pop up from the tree. Duplicate the tree, rotate it by 90 degrees, and scale it to 20%. Place it on the side of the main tree, in the center of crown, and parent it to the main tree. Now let's create a transition to another state. Select our tree, open its position, scale and rotation properties. We can animate it in the following way, so that the branch will have the size of original tree. And the original tree will be rotated by 90 degrees and turn into ground. Cool! Now parent the ground to our tree and see what we got. Now let's make sure that the first and last frame have the same look. We will be using Screenshot tool for that. Go to first frame and make a screenshot. Go to the last frame and compare them. Make them have no difference. Cool, they are the same now. Now we need to make the branch appear by animating its rotation and bend. Set the rotation to -30 and bend to -100. Then move 10 frames further and make the bend 0 and rotation 90 degrees. Add bounce expression to these properties. And make the speed graphs of the following form. And remember that the last keyframe shouldn't have the 0 speed. Now let's make easings on original tree. Rotation will have really smooth start and end of movement. Such a strange form of graphs is prompted by one interesting optical illusion that occurs when asymmetrical objects are approaching to the camera. It seems like they're slowing down a little in the last moments. In case to compensate the effect of this illusion, we need to slightly increase the movement speed as camera zooms in. There is no clear recipe for perfect graph shape for these cases. It depends on animation you are working on, and it's usually done by sight. Perhaps the most interesting type is combined loop. This can be met most frequently. For example, we combined continuous loop of horizontal movement, loop of offsets with fighting ducks, and the first example just simple loop of swinging tree, and that's all in one animation. Now let's sum up. We have learned 5 main types of animated loops. Ordinary loops of repeated movements, loop with offsets, continuous loop of linear movement, recursion, and combined loop. We also find out how to loop path animation and learn new loop out types. So in general we can use 4 types. The first one is cycle. It repeats the animation between first and last keyframes. Ping pong, which plays animation back and forth, and offset and continue. The easiest way to see the work principle of loop out offset is on the example of ball jumping on stairs animation. We loop the one jump and each next starts from the end of previous. Continue loop out type is useful in cases we need to loop linear movement. Create a keyframe on rotation property, then move 20 frames further and change the value to 180. Now play the animation. And you see that it continues rotating even after it reaches value of 180. Loop out took the speed from the last keyframe and created the continue of movement using this speed. So by changing the interval between these 2 keyframes, we can control the speed of rotation. And let's get ready for the homework. We challenge you to create recursion loop, so your task is to recreate this shot with clocks. And we also will be glad if you come up with your own ideas about from what and how to create recursion loop. Or if you try to create all types of loops in one scene. But attention, task with clocks is compulsory. So good luck to you and see you on the next lesson.